This is Mr. Beck Does Your Homework, AP Physics, Homework 4.3, question number 12, another ladder problem. A 17.5 kilogram person climbs up a uniform ladder with negligible mass. Good, we don't have to worry about the ladder's mass. The upper end of the ladder rests on a frictionless wall. The bottom of the ladder rests on a floor with a rough surface where the coefficient of static friction is 0.12. The angle between the horizontal and the ladder is 65 degrees. When the person attempts to climb the ladder, how far up the ladder will the person reach before the ladder slips? Kaboom! The acceleration of gravity is 9.8. So what I've got is this ladder. I know that there is a normal force this way. There's no friction up here because it's frictionless. So I've got a normal force pointing out this way. I have the gravity on the person, 17.5 kilogram person. Well, I'm going to have to multiply that by 9.8 to get my force of gravity on that guy. On this point, I've got a normal force this way. And I've got friction. Well, friction, the ladder would slip out this way were it not for friction. So friction is going to be pointing in this way. So I've got one force there, another force there, another force there. I could figure out what most of these forces are. This one easy, 17.5 times 9.8. This is the only upward force. So this one is down, this one must be up. So I know that for the person, this force is going to be 17.5 times 9.8. So that's easy. This force up, this normal force, is the only other upward force. So my upward force must equal my downward force. So I know this is going to also equal the force of gravity on the person. This frictional force to the right, I'm not sure what it is, and this normal force, I'm not sure what it is. But I know that this normal force and this frictional force have to be the same because left equals right. So up equals down, left equals right. But I do know that my force of friction is going to be mu times my normal force. And my normal force already is going to equal, this normal force over here is going to equal the force of gravity down. So this Fn equals Fg. So this one is easy to figure out. So my force of friction is going to be my mu of 0.12, my coefficient of friction, times my normal force, which is 17.5 times 9.8. So now I know what my force of friction is. So that'll also give me this normal force, so I can put that in either one of these places. So I know all my forces, but this question is asking, when the person attempts to climb the ladder, how far up the ladder will the person reach before the ladder slips? So I'm looking for this distance. Now where should I pick as my pivot point? I could pick any point. But what's going to happen when the ladder slips is this person will walk up enough that the torque will get so much that friction can't handle it, and the ladder will slip kind of this way. So I can think of it as pivoting either from up here, either on this point pivoting this way, because it'll spin clockwise a little bit, or I could think of this pivot point up here and let it spin this way. So either one will work for this problem because I know all my forces. But I'm going to pick this bottom point because this distance is what I'm looking for, so that'll just make my math slightly easier. So if I pick the bottom point as the pivot point, then this gravity on the person is a clockwise torque. This normal force is a counterclockwise torque, and I've just got those two that I'm dealing with. So I'm going to have counterclockwise equals clockwise. So counterclockwise is going to be this normal force, this one up top. So I should maybe call that the force of the wall or something. So this one up top is going to have an RF sine theta. And when it equals this gravitational force, then I know that I've hit the point where it's going to slide. So this gravitational torque. So that's going to be an RF sine theta. This R is going to be from this pivot, the length of the ladder. So this length is going to be 4.8. This force, this normal force up here, is going to equal the force of friction. So I've already figured out what the force of friction is going to be because that was the other normal force, the force down here, times mu. So this force of friction to the right has to equal this normal force to the left. This force of friction has to equal this normal force. So this one is the normal force. So that's going to be my 0.12 times 17.5 times 9.8. I'm just going to write FF right now. Now sine theta. What theta is going to be this right here? Because here's my radius and here's my theta. Well, these are alternate interior angles, so that's going to be 65 degrees. This is going to equal the person. So R is what I'm looking for. That's actually the distance the person is. The force is going to be the force of gravity. So that's going to be 17.5 times 9.8. So that's the force of gravity. And sine theta is what I need to figure out here. What's that theta? The theta here is between the radius for the person and the force of the person. So this angle here is going to be 90 minus 65. Now, I know 4.8. The force of friction is this that I figured out before. Sine 65, got it. Distance I'm looking for, there's 17.5, 9.8, sine of 90 minus 65. I am all set to solve for G equals, and that will be when the ladder will slip out from under the cap.